Hello everyone. Today we are going to discuss about special discrete distribution. So in this lecture, we are going to talk about uniform distribution, a discrete version. Usually you will see a uniform distribution under a continuous setting, but for this discussion, we are going to talk about discrete uniform distribution. So let's say x is a random variable which can take 1 to n. Then it follows uniform distribution if it is probability function given by this formula. Let me draw just to make just to be clear what this means. So if this is random variable which take discrete value, and if this side show the probability mass function, then we have like 1 all the way up to n. And then the probability is 1 over n. So you can draw something like this. If this is 2, and then this is 1 over. So the idea would be it doesn't have to be need to take between 1 to n. It can be like something like 2, 4, 6, 8. What it says basically, the probability need to be same, or 1 over n, number of the values random variable can take. Okay. So for example, let's say x can take 2, 4, 6. Then I can, then x is going to be uniform if probability x equal x is just 1/3. Okay. So if I draw this new one, here I have 2, 4, 6. Then here's the 1 over 1/3. That's the probability. Now remember that when you add, why is 1 over n, or 1 over number of, the values random variable can take. That's because when you add probability, it need to be 1. Remember that we have this formula, sum of total probability need to be 1. Okay. So if you have n values, then by taking sum of 1 over n, 1 over n for n times, you would end up with n over n, which is 1. So that's why you have 1 over n. So this kind of distribution we call as discrete uniform distribution. So next, I include few formulas, which is very useful when you do calculations. So just to be familiar with this formula, even in exam P, sometime remembering this formula is help you. So for example, these two, you can see it's sum of I, like if you wanted 1 plus 2 plus 3 plus all the way up to n, then the sum is going to be n time n plus 1 over 2. And this is more like if you want to add 1 square plus 2 square all the way up to n square, then the sum is going to be n time n plus 1 over plus 2n plus 1 over 6. Then you have this geometric series. If you remember, this is sum of geometric series. And then here you have this adding up to infinity. Remember that if x, absolute value of x is less than 1, then you can send this to 0, and then you end up with a over 1 minus x. So this is basically extension of the previous formula. And then you have the definition kind of the exponential function. So just keep these things in mind. Then you can use it when you're doing exam P, and also in this lesson. So here you can see that the question asks, if x follows finite discrete uniform distribution, where x take these values 1 to n, then show that x value is n plus 1 over, if not n, is 2. Okay. And variance of x is this. So let's try to prove this, one of this. So let's try to prove x value of x. What's the formula? That's sigma from previous lesson. sum of x time probability x equal x. So this is basically, since x taking only 1 to n, you can say this goes from 1 to n, probability x equal little x. So if I do this, this goes from 1 to n. And the probability is going to be 1 over n. That's the probability mass function for uniform. So you can take 1 over n outside, and then you are just adding x equal 1 to n x. So this is, that sum is given in this form in here. Okay, you can see that. In there you see I, but in here you see x. So you can substitute that. The sum is going to be n times n plus 1 over 2. So you cancel out, you end up with n plus 1 over 2. The same way you can calculate variance of x, but before that you can first calculate the second moment. If I use the definition, x square probability x equal x, which is going to be again x equal 1 to n. And the probability is going to be still 1 over n. So which you can take outside 1 over n. And then you can substitute this one. We already have formula here. N times n plus 1 times 2n plus 1 over 6. So if I substitute that, n times n plus 1, 2n plus 1 over 6. Okay. So now you can, so this is cancelled out. And now you can calculate the variance of x, which is ex square minus ex square. So that's going to be n plus 1, 2n plus 1 over 6, minus you have to square this one. So you can take the n plus 1 as common factor. So here you have 2n plus 1 minus n minus 1. Oh, I have taken one. So, I have 4 times 2n plus 1 minus 6 times n plus 1 over 24. We can simplify this. 8n plus 4 minus 6n minus 6 over 24. So here you have n plus 1. So 2n plus 2n minus 2. So that would end up as n plus 1 time n minus 1 over 2n. By the way, this needs to be corrected. Okay. Yeah. So check it again. I think this formula need to be corrected. Okay, so the next example asks, now what happens if x follows uniform distribution but take 2, 3, 4, 14. So x take in not 1, 2, 3 like previous, is just take 2, not take 3, 4, all the way up to 14, not 1. Okay. So again, you can see that there are 13 values here. Okay, so then that means probability x equal x is going to be 1 over 13. Okay. X can take only 13 possible values. Random variables can take only that. I mean, this is a function, remember? So the image is going to be on the size of image is going to be 13. So probability mass function is 1 over 13. If you draw this, here you have x. This side you have probability x equal to x. You start from 2 all the way up to 14. And then this is 1 over 13. Okay. So everyone is 1 over 13. Okay, so the probability mass function is 1 over 13, and you can calculate that cumulative distribution function. Okay. What is that? Cumulative distribution function. Distribution function which we use CDF, that probability x less than or equal x. Okay. So for example, if I want to calculate probability x less than or equal 4, that's same as saying probability x equal to, because it's discrete, plus probability x equal 3 plus probability x equal 4. So that would be basically 1 over 13 3 times. Okay. I can also calculate probability x less than, let's say, 2.7. Now that's going to be just probability x equal to, okay, which is 1 over 13. Okay. Now remember, if you graph this, it's going to be like a step function. Just graph it and see. And then also you can calculate the mean and variance. It's going to be different, okay, because you're not starting from 1. So you can't use that formula. You have to recalculate it. Okay. For example, if I want to calculate Ex, that's going to be sum x. So now this one starts from 2. Okay. 2 times 1 over 13. All the way up to 14 times 1 over 13. So since it's not from 1, you have to do some modification and get the answer. The same for the variance. Okay. So you can't use this formula right away. Here you see another question. In this question, they didn't give you the b, but you can calculate. Assuming it's 5, 6, 7, 8. There's no value skip in between. Okay. So let's say x goes from 5, 6, 7, all the way up to b. Okay. We don't know b. Then we know that the probability is 1 over 10. So using that sum, total sum need to be 1, we can calculate b. Okay. So you can see that if it is 8, 1 over 10, so 1, 2, 3, 4, 9, 1 over 10, 1, 2, 3, 4, 5, 10, 11, 12, 13, let me add. So total probability is what by this point? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you add here the total probability x equal x, that's going to be 1. So that means you cannot add more values. So b should be 14. Okay. So that's how you can get the b. Once you know the b, then you can calculate mean. So basically, you use the formula. So in this case, you have 5 times 1 over 10, 6 times 1 over 10, all the way up to 14 times 1 over 10, and 1 over 10 is common factor. So you can take 5 plus 6 plus all the way up to 14. Okay. And then add that, and then you get the answer. And the same for the variance, you take the second moment and you can find the variance. So that is uniform distribution. Next one, we are going to discuss about Bernoulli trials and Bernoulli distribution and binomial distribution.